back and look at it. So let's find f of x. When is f of x equal to 0? Well, that's easy. Where? -3, 1, and 4. Everybody comfortable with that? -3, 1, and 4. If you're not comfortable with that, you're in trouble. Okay? This is f of x. When is f prime of x equal to 0? That would be where we have horizontal tangents. I have a horizontal tangent where, guys? At -2. Where else? I have a horizontal tangent at 2 and at 4. So -2, 2, and 4. Okay. On what intervals is the function increasing? Well, it's increasing from -2 to 2. Oh, okay, hold on. Is this -2 or is this negative? It looks like it's more, I'm zooming in. It looks like it's more, can we back up on this? Can we call that -1.5? That looks more appropriate, doesn't it? Okay, let's fix that. So when is, I'm going to erase, it was this one right here, -1.5. Anybody else kind of think it was that too? Is the 2 and the 4 though, we okay with those? So then when is my function increasing from -1.5 to 2? So from -1.5 to 2, and then again from 4 to, what does it give me? It never gave me boundaries, so we got to say 4 to infinity. Okay? Now, I know it's not on your paper, so I'll just say it, you write it, okay? The next question says, when does f of x have a relative minimum? I have one of them right here. Where? Relative minimum where? -1.5. You know that because you went from decreasing 0 tangent to increasing. So that's a relative minimum. It's also the what? It's also the absolute minimum. Okay? We have another one though. Where's our other relative minimum at? 4. Because we went from decreasing horizontal tangent to increasing. Okay. Next question, number 5 asks, when does the second derivative equal 0? Explain your reasoning. When does the second derivative equal 0? When we have a what? Point of inflection. So that would be where the concavity changes. Okay, follow my cursor. Here we go. Concave down, or excuse me, I said that completely wrong. This is concave up. Whoa, boom, right here. You see where the concavity changes from concave up to concave down? So where do I have a second derivative equal to 0 at? 0. So everybody's writing 0. Yes? Okay, then continue. Here's our curvature. 0. Concave down. Boom, right here, point of inflection. See how it changes from concave down to concave up? So we have a point of inflection where? At 3. Okay. Can you answer that last question, 6? When is the second derivative negative? Explain your reasoning. So I'll come over here on the side. I'll put numbers. I want to write down number 6. When is, the question asks, when is the second derivative negative? Anybody think they know it? Matthew? From when to when? What interval? Second derivative tells us concavity. Say it louder. 0 to 3. Why? You're right.
Because that's when they change from concave up to concave down.
You don't even have to say change. This is where it's concave down. So the second derivative is negative. So wouldn't the derivative be wouldn't the derivative be positive from negative infinity to 0? And again, the second derivative would be positive from 3 to infinity. Cool? Okay. Continuing here. So this page has nothing to do with the first page. Why? This is, even though it's the exact same graph, this graph now is the what? What does it say? This is now, it's saying this. This is g prime of x. This is a whole new graph, a whole new function. This is the derivative graph. So everything we did in the first page, ignore. New graph. Okay? This is the derivative. Maybe you need to make that note. Derivative graph now. Okay, ready? It starts off with trying to trick you. Can the derivative tell you where the original function's 0? The answer is no, it can't. I can't answer that. I saw you shaking your head there. I won't say your name, so it's not on. You cannot answer. How is the derivative telling me when the original function's 0? So I got a question. When does the derivative equal 0? The derivative is equal to 0 where, guys? At -3, 1, and... Okay, let's write that. So we do know that. I know when the derivative is, because I gave you a negative. Give you the derivative graph. And that's the x-intercepts of the derivative. So now, the next question says, when is g of x increasing? Look up here. This is g prime of x. This should be easy. G of x is increasing when g prime of x is positive. Where's it positive at? From negative infinity to -3? And from 1 to 4. Nice. And from, see how I had to say 1 to 4? And from 4 to infinity. Careful there. Okay? Okay? All right, here we go. Now you can't see them, so I got to read them. So be patient with me as I try to read this. Number 4. When does g of x have a relative minimum? When does g of x have a relative minimum? Ms. Horde, I'm making you answer it. What do you think?
Okay. Well, it has to be at one of the zeros.
Okay. She's right. Because that would be where your derivative is 0. So that would be a horizontal tangent.
I think it's at 1.
That's correct. Everybody write at x equals 1 for number 4. So she said at x equals 1. Can you justify it?
Because it's a negative turning into a positive, so that means on the f or g of x graph would be decreasing to increasing.
Correct. If the derivative is negative, that meant what of the original graph? It was what? Decreasing. 0. If the derivative is positive, that meant what of the original function? Increasing. Isn't that a relative min where you go from decreasing to increasing? Ah, very good. So, I don't think I asked it. What's negative 3 then, guys? That's a relative maximum. Because it was increasing, the derivative is positive. Decreasing, the derivative is negative. So that was a relative maximum. This is not a relative maximum. Look, increasing 0 and continuing to increase. Nice. When does the second derivative equal 0? So this is the first derivative. Wouldn't the second derivative be equal to 0 where there's tangents of 0 for the first derivative? So where we're going to say at negative, remember this isn't negative 2, this is what? Negative 1.5, 2, and 4. Oh, now, go ahead. Ask the question.
Okay, can you explain how you know which one's the relative maximum and which one's the
Yeah, I can go back to relative maximum. So are you comfortable with this is where the derivative is 0?
Yeah.
Okay? This is the derivative graph. If the derivative is positive, doesn't that mean your original function was increasing?
Mm-hmm.
If the derivative is negative, doesn't that mean your original function is decreasing? Increasing, 0, decreasing. Wouldn't that be a relative max? Look at me. Increasing, 0, decreasing. Okay, follow me here. Let's do this. This is a 0. The derivative is negative. That means your original function is decreasing. 0. Derivative is positive. That means your original function is increasing. Look at me. Decreasing, 0, increasing. That's a relative minimum. Okay? What question am I on now? 6. When is the second derivative negative? Which means when is the second derivative? Which means when is the original function concave down? What's the definition of concavity? It was the first thing I had you do. I wrote the formal definition down. I had you write it down. The definition of concavity was it's concave down. Look up here. Don't look it up. I'm going to say it. It's concave down when the derivative is decreasing. It's concave up. Follow my cursor. When the derivative is increasing. Concave down, concave up. Why? Because this is the derivative graph. Agree? What's the slope of every tangent line if your graph is decreasing? The slope is what? Negative. That means the second derivative is negative. And doesn't the second derivative, if the second derivative is negative, doesn't that tell me concave down? If the second derivative is positive, doesn't that tell me concave up? So here we go. When is, number 6 said, when is the derivative, second derivative negative? It would be from negative infinity to negative 1.5 and from 2 to 4. Because g prime of x is decreasing. So ready? Where's my points of inflection at, guys? At negative 1.5, because I went from decreasing, 0, increasing. There's a point of inflection where at 2, because I go from increasing to decreasing. And there's a point of inflection at 4, horizontal tangent 0, and I go from decreasing to increasing. So new graph. This is the second derivative. When does h of x equal 0? You can't answer it. You don't know. You don't know. So let's see if you can put 2 and 2 together. Number 2, when does h prime of x equal 0? I don't know. 3. When is h of x increasing? Does the second derivative tell me anything about increasing or decreasing? What derivative tells me increasing and decreasing? First derivative. Can't answer. I need more information. I don't have it. I don't know. When does h of x have a relative minimum or relative maximum? I don't know. Question mark. You're like, this is great. You got a whole page of question marks. Okay, what number am I on? 5. Oh, we get to answer 5. When does the second derivative of x equal 0? Well, that's easy. -3, 1, 4. When is the second derivative less than 0? That's easy. Where our graph's negative. Where's our graph negative at, guys? -3, 2, 1. Why? Because the graph's below the x-axis. What's that mean then? If my second derivative is negative, the original function was concave down. So let me ask you this. Let's look up here. It's not on your worksheet. It's not on your worksheet. Where's the second derivative positive? Here and here and here, right? What's that tell me? The original function was concave up. So then 7 asks, when does the original function have points of inflection? When the second derivative is 0 and concavity changes. So there's 2 points of inflection. At -3, because you went from concave up to concave down, and at 1, because you went from concave down to concave up. Why not 4? Second derivative is 0. It stayed concave up, 0, and then went concave up again. So we did not change concavity.